Okay, problem 5. So now problem 5 is similar to problem 4, except now we're finding the pH instead of base, of acid, which is, this is the ammonium ion. Okay, so let's go ahead and start with our reaction first. Our reaction would be starting with this, initially, NH4 plus, sort of like hydronium ion is H3O plus. This is just ammonium ion. So there's acid in here because there's an extra H that's present. We write this reaction as going to NH3, which is conjugate base, plus H plus. So this is acid, this is conjugate base, and then this is our H plus. So now let's set up our ice table. Initially we start out with 0.1, we love doing that. Then we move on to having zero ammonia and 0 H plus. Our change, we know that this is a weak acid, so it's partially dissociating. So then our equilibrium concentrations are 0.1 minus X, X, and X. And we are looking for pH, so that means that we are going to need our X to figure out our concentration of protons. And so all we need to do then is use the relationship, the Ka being equal to the products over the reactants. And the Ka for ammonium ion, we look that up. We can look up that information. We use table 16.5 to find this information. To find the Ka of NH4 plus, it gives us Kas of acids, and it gives us conjugate bases. So we're covered. We find out that our Ka is equal to 5.6 times 10 to the minus 10, which is then equal to X times X over 0.1 minus X. Now, we're back to, can we use our approximation to solve for X? I think that we can, because if we put in the Ka over the initial acid concentration, it's going to be very, very small. Why do we know this? Because this is to the minus 10. That's super small. So you can just eyeball it and know that you're going to be straight. So we're going to assume that this is super small. That goes away. And so then we're left with 5.6 being equal to X times X all over 0.1. Solve for X. And we find that X is equal to, what did I find it to be equal to? 7.48 times 10 to the minus 6 molar. Okay, so this then is equal to our H plus concentration, which is here in our ice table, right here, right? Okay, so now that we have that, same old thing. pH is equal to the minus log of 7.48 times 10 to the minus 6. So then pH ends up being equal to 5.12. And that's our answer. Now, our answer is reasonable because we are asking for the pH of an acid. This is a weak acid, but it's an acid. And we know that acids have lower pH. It's lower than 7. This is lower than 7. This makes sense. Life is good.